So this is an earthquake recorded at Forge. This is depth and this is time. And what we think this is actually an event that is refracting off the granite. So that would be a very shallow earthquake that goes down, finds this high velocity granite contact, and then starts grazing along it. And the reason we think this is the case is that there is almost no signal below this kind of cutoff line. And we see that the first arrival, even if you would continue this, the first arrival is somewhere along the middle of the array. And we know the granite contact is around this area. So we think this is a refraction event. And it's cool because this is something that's very hard to get from field data. And it's also cool because this is an event that does not abide to our assumptions. We did manage to detect it nonetheless because some of the portions of it can be approximated to match our assumptions, but we think it's a refraction event from the granite. If you have other ideas, let me know. Paper's still not published yet, so I could change the interpretation.
Excellent. I think that was a really cool example of, we tried in this kind of today to kind of expand the view of what DAS could be and also show kind of a lot of different examples of where DAS data are being used, where geophones can't be necessarily used. And so I think you've seen kind of in mines and in kind of pipes and down wells and in kind of telecom installations and many different applications spanning many different frequency ranges. And so hopefully this kind of gives you a sense of whether you're looking at strain or very high frequency dynamics, DAS is kind of a useful tool to begin to use on these.